Welcome to this session on mean value theorem. In this particular session, I am going to discuss about the Rolle's mean value theorem. But before going to the Rolle's mean value theorem, let me introduce to you a bit of history of mean value theorem, that where in the literature first time the result similar like mean value theorem has been introduced. Now we found that the result similar like mean value theorem has been first presented in Siddhant Deepika by Parmeshwara. He was an Indian mathematician from Kerala School of Astronomy and Mathematics. He presented this result in his first commentary on the commentary of Gobinda Swami and on Bhaskara first, the name Bhaskarya. Parmeshwara gave some of his eclipse observation in this work, including one made at Nakshetra in 1422 and two made at Gokarna in 1425 and 1430. This work also contained a mean value type formula for inverse interpolation of sine. So this particular result is shown in so many places into the literature as well as in archive. There are some articles also have mentioned this. The original literature written by Parmeshwara was in Sanskrit, but different researchers have used it in their work. Now a restricted form of the theorem by Michael Rolle in 1691 has been presented first. Now the statement of Rolle's theorem, what exactly it says? If a function fx is following certain condition, then we can apply Rolle's theorem on it. Now what is the first condition? Fx is continuous on a closed interval AB. Remember, we always talk continuity either at a point or in closed interval, because at one particular point we can define the continuity of the function. So we can define the continuity even at the end point also. Second, so here, before going to the second, if you look at this graph, my function fx from the point A to point B, it's continuous. Now exactly what does mean of continuous from the point A to point B? It means for every x between A and B, fx is existing. There is no x between A and B at which fx is going to infinite or it is not defined. So for every x between A to B, fx is existing. That is the meaning of continuity. Second point, fx is differentiable on the open interval AB. When we say fx is differentiable on the open interval AB, means function is differentiable in the interval AB excluding the endpoint. Why we are excluding the endpoint? Because differentiability at a point can be defined. But here, when we are going to the endpoint, my function is defined right to the A as well as left to the B. So at the end point, if I try to define the differentiability, I will be defining it right differentiable as or left differentiable. I won't be able to define the differentiability of the function. That's why differentiability at the end point is excluded. The third requirement of Rolle's theorem is function should have the same value at a starting and end point. Means f of A should be same as f of B. Now if you look at this graph, from A to B, function is continuous, it is existing for every x. Function is differentiable. How we can understand geometrically that this function is differentiable? A function is differentiable at a point if at that particular point of the function we can draw a tangent. And if that is a unique tangent, then we say that this function is differentiable at that point. So if from the point A to B we look at this function fx, it is differentiable, means I can draw the tangent at every point and that will be a unique tangent, so it is differentiable. And the third requirement, f of A is same as f of B, means Rolle's talks about this kind of curve. Then he says that there exists at least one point C. There exists at least one point C in the interval AB, means between A and B, somewhere there will be a point C such that f dash C will be 0. F dash C will be 0 means function's derivatives value at x is equal to C will be 0. So this is can be understood from this diagram. If you look at that graph, from A to B function is continuous, from A to B function is differentiable, and at f of A and f of B both are equal. Then between A and B there exists a point C at which if I draw a tangent to the curve, f dash C, what exactly it represents? It represents the slope of tangent which is drawn at the point x is equal to C on the curve. So at the point C on the curve, the slope of tangent will be same as the slope of x-axis, means it will be parallel to x-axis, that means it will be 0. That's what the Rolle's theorem statement is. Now there comes a question that why the word at least is used in this theorem. Why the word at least is used? Now if you look at this diagram, from the point A to B, this is again a continuous curve and a differentiable curve, and at the point A and at the point B functions values are same. That means this height as well as this height both are same, and between A and B there is not only one point C but there is a point C, D as well as E at which we are going to get the slope of tangent 0, means the tangent will be parallel to x-axis. So actually Rolle's wanted to say about the at least one point C will definitely exist, because the previous diagram which I have shown it to you, there is one point C, but there could be more point also which is shown in this diagram. This is the statement of Rolle's theorem. Thank you.